services, the service that we have on AWS for migrating and in a lift and shift fashion. And after that, we will be done with our presentation. So let's get it working. Migration journey. Migrating large-scale workloads can be challenging, and to simplify the process, we have defined different phases for a migration journey. There are 3 phases in our approach to complete large-scale migration. Once you have completed your migration, the next thing to do is to optimize those workloads migrated. First, it's an assessment phase. It's where we build a business case and perform a cloud readiness assessment. Here we will talk about the value proposition of the cloud, cost analysis, incentive programs, and such. As an example of a popular program we recommend our partners do in our customers' environment is the Optimization and Licensing Assessment, or OLA, or OLA as the acronym goes, through which we not only assess and right-size the customer environment, but also go through the licenses they've purchased throughout the years and give them recommendation on how to get the best of them, specifically if they want to use them on AWS Cloud. Let us know if you're interested to know more about the OLA program, and we'll make sure we connect you to the right resources. The second phase is the mobilization phase, in which we build an AWS architecture as well as a migration plan and mobilize businesses to migrate at scale. And finally, the third is the actual migration and modernization phase, where we move workload to AWS and put a cloud operating model in place to run and optimize for further business benefits. In this presentation, we're going to focus on migrate and modernization phase with a focus on Microsoft-based workloads, what tools we have, what are the common practices, and how you can assure a successful migration, depending on the workload. If you look at different layers of Microsoft workloads, usually identity and Active Directory is the core of the application for authentication and authorization. Then usually we have Microsoft SQL Server for the database layer, and then .NET applications which work with Active Directory and SQL Server. Let's talk about different options and patterns for migrating Active Directory first. There are different patterns that customers follow to migrate their Microsoft Active Directory to the cloud. Here, we'll be covering 2 of the most common use cases. The first option is self-managed Active Directory on EC2. EC2 meaning Elastic Cloud Compute. Being partners, you already know this acronym. This option requires customers to promote their domain controllers in EC2 and then manage it themselves. The second option is to use AWS Managed Active Directory, in which AWS manages Microsoft Active Directory and also allows more integration with other services. Let's drill down into each of the scenarios. With self-managed Active Directory on EC2, basically you will be required to create Windows Server EC2 instances and then promote them to be domain controllers and make them either additional domain controllers for your existing domain or a new Active Directory domain in your forest. It could be a new tree, it could be a subdomain, whatever the architecture feels comfortable. Of course, this requires proper network connection between your on-premises and cloud, which can be accomplished by different technologies, for example, AWS Direct Connect or AWS Site-to-Site VPN. Customers usually deploy domain controllers in different availability zones for fault tolerance, just in case an availability zone in a specific region goes down. Using this approach, you'll be able to extend the same Active Directory domain as your on-premises, and it can use the same schema, user, and configuration as your on-premises AD. Because you're building and operating the AD yourself, you will get full administrator access to the domain, and with that, you can establish trust or just add additional domain controllers to replicate with your on-premises ones. It also allows you to load applications which require full domain administrator permissions, like Microsoft Exchange. For high availability, you can create your domain controllers in multi-region and multi-availability zone. How about the managed AD though? So what is actually a managed AD? It's a single forest, single domain, Microsoft Active Directory domain services deployment, which AWS deploys, manages, and maintains the infrastructure piece of it. It's not an emulation, it's not an open source thing, it is an actual Microsoft Windows-based Active Directory implementation. When you launch AWS Managed Active Directory, it creates a highly available pair of domain controllers connected to your VPC. And the domain controllers need to run in different availability zone in a region of your choice. The host monitoring, recovery, data replication, snapshots, and software updates are automatically configured and managed for you. So you, as the customer, won't need to worry about undifferentiated heavy lifting of maintaining an Active Directory environment once it's loaded onto AWS. Depending on your scaling requirement, you can add more domain controllers or even add more regions to your managed AD instance. Of course, that depends on the addition of the or the SKU of the managed AD you have deployed. With AWS Microsoft Active Directory, you can run their directory-aware workloads in the AWS cloud, including Microsoft SharePoint and custom .NET and SQL Server-based applications. You can also configure a trust relationship between AWS Managed Microsoft AD in the AWS cloud and your existing on-premises Microsoft Active Directory, providing users and groups with access to resources in either domains using single sign-on. You can also use seamless domain join feature to join your EC2 instances seamlessly to Active Directory. How will it help us in a migration project? Well, we have a few options here. Your option one will be leave the on-premises Active Directory the way it is, set up the trust between the managed AD and on-prem, and join your servers to the managed AD. In this scenario, managed AD will be our resource forest and on-premises forest will be our account forest, as it goes in the Microsoft terminology. Your second option will be to migrate the actual users, groups, computers, using tools that are supported by managed AD, such as Microsoft's own Active Directory Migration Toolkit, or ADMT as the acronym goes. We're working on some tools and processes to make this approach easier. And if you have customers who can benefit from such scenarios, let us know and we can get you connected with the product team which is working on these tools. They're interested in talking to your customers and gather more data about what the requirements of customers are so that they can actually tweak the tools that they're developing to match with your customer requirements. How about SQL Server? There are different patterns to run Microsoft SQL Server in AWS. First is to run SQL Server on an EC2 instance. In this scenario, you create and manage the EC2 instance that's running the SQL Server, and you will get full access to the operating system and SQL Server database engine. Here, you will be in charge of backup, maintenance, and patching for the SQL Server and the operating system. But with this option, you can bring your own license for SQL Server, and with doing that, you'll have the option of changing the underlying OS from Windows to Amazon Linux, Red Hat Linux, Ubuntu Linux, or any other flavors of Linux that support both SQL Server and they're supported on AWS Cloud. Another option is to run Amazon RDS for SQL Server, which is a managed SQL Server service. Amazon RDS for SQL makes it easy to set up, operate, and scale SQL Server deployment in the cloud. With Amazon RDS, you can deploy multiple editions of SQL Server in minutes with cost-effective and resizable compute capacity. Amazon RDS frees you up to focus on application development by managing time-consuming database administration tasks, including provisioning, backups, software patching, monitoring, and hardware scaling. There are different paths and tools that will help you to migrate Microsoft SQL Server to the cloud. AWS Database Migration Service, or DMS as the acronym goes, it connects to and migrates your MS SQL data. We offer AWS Application Migration Service as well to enable you to migrate your entire virtual machine. We'll see a demo of that later on. Lastly, we support use cases where there's a need to leverage native Microsoft SQL Server like backup and restore, or log shipping, or distributed availability groups, which helps with migrating the SQL database. First, let's look at the Database Migration Service, the DMS. Migrating databases can be challenging when moving from on-premises to cloud or from one relational database engine to another. AWS Database Migration Service is a cloud service that makes it easy to migrate relational databases, data warehouses, NoSQL databases, and other third-party data stores. During a migration, the source database remains fully operational, minimizing downtime to applications that rely on the database. To perform a database migration, AWS DMS creates a DMS replication server which connects to the source data store, reads the source data, and formats the data for consumption by the target data store. It then loads the data into the target data store, and most of this processing happens in memory, though large transactions might require some buffering to disk. AWS DMS supports, as a source, a variety of Microsoft SQL Server versions, from SQL Server 2005 to SQL Server 2019, and different editions like Enterprise, Standard, Workgroup, Developer, and Web Edition. AWS DMS also allows ongoing replication for SQL Server, which uses native SQL Server replication for tables with primary keys, and change data capture, or CDC, for tables without primary key. And as part of the DMS, you actually have the option of changing the database engine as well. So for example, your source can be Microsoft SQL Server, but your target could be MySQL or Aurora Postgres. And this is one of the tool sets that will make your database transition smoothly to AWS Cloud. How about the lift and shift? Application Migration Services, or AWS MGN, can be used to migrate your MS SQL Server instances. There are many lift and shift occasions through which you would need to bring in the entire operating system and the application the way they are into AWS. Migrating VMs can be challenging, coordinating a migration period that does not impact the business, and configuring networking to accommodate the bandwidth and connectivity requirements. AWS MGN helps you simplify, expedite, and automate large-scale migrations to AWS. It's a block-level replication tool that continuously transfers deltas of your attached disks to AWS and stores them as EBS snapshots. You would use these snapshots to create EC2 instances with the same content as your on-premises servers. Naturally, you can use it for all other purposes than SQL as well, of course, with some caveats on clustered environments or distributed systems like Active Directory domain controllers. We want to make sure that in those distributed scenarios, the brought up instances don't conflict with the original instance or is in coordination with the other instances of the distributed system, like Active Directory. So there are caveats there. To migrate your VMs, you need only to install an agent on each VM and then use the AWS Application Migration Console to define your replication settings to replicate your MS SQL instances. Actually, in the scenarios that your virtual machines on premises are running on VMware, you can even skip the installing the agent part on each VM and just use an appliance that will integrate with the VMware vCenter and uses VMware technologies to do this delta replication. So you might be even able to skip the agent installation part and just migrate them in bulk. Later in our presentation, we will demo creating a replication of your instance using the AWS Application Migration Services Console that my colleague Siavash has created for you. What if you want to migrate your SQL Server using native tools without relying on any third-party tools? Distributed availability groups is a native SQL Server feature which supports two completely different availability group configurations. It enables not only easier disaster recovery and multi-site scenarios, but also migration scenarios. Whether you're migrating to new hardware or virtual machine, configuring a distributed availability group allows a migration to occur where in the past you might have used backup and restore or lock shipping for the same purpose. Initially, when you configure the distributed availability group for migration, the data replication will be set to asynchronous, so it won't impact applications that are still relying on the on-premises database. When you get close to the cutover time, you stop all availability traffic to the original availability group, and you set the distributed availability group replication to synchronous mode. This action ensures that the primary replica of the second availability group is fully synchronized with the source database. So there will be no data loss naturally. After you verify the synchronization, then you can cut over to the secondary group and we'd be done with your SQL Server migration. So we talked about authentication piece, we talked about the SQL piece, now the application portion. There are different patterns and platforms to run .NET applications in AWS. First option is to rehost, otherwise known as lift and shift the application to Amazon EC2 instance. This can be done using tools that we already discussed. Mainly the most recent one will be the AWS MGM, but you might have used other tools like Server Migration Service or Cloud Endure in the past, or even VM import and export. Second option is replatforming, in which you might make a few cloud or other optimizations in order to achieve some tangible benefit, but you're not otherwise changing the core architecture of your application. For example, you may migrate your application to a fully managed platform like Amazon Elastic Beanstalk, or if your application is container-based, you can run it using AWS Elastic Container Service or AWS Elastic Kubernetes services. And our third line of option is refactoring or re-architecting, which is reimagining how the application is architected and developed, typically using cloud-native features. This is usually driven by a strong business need to add feature or to scale the application or scale the performance of it. That would be, and usually those incentives are otherwise difficult to achieve in the application's existing architecture. For example, when you move from a monolithic application to a service application, you need to change the architecture of your application, but you will get the greatest scale that the cloud-native tools will provide for you. Let's look at these options from a different perspective. In 2016, Microsoft released a brand new software development framework called .NET Core. .NET Core can run everywhere that .NET Framework can. However, it can also run on Linux, which naturally means it can run on AWS serverless compute platform. And this is a big advantage of .NET Core over .NET Framework. Since then, the terminology has changed, and today, when you simply say .NET, you're referring to the open source framework that works across platforms. If you want to refer to the older Windows-specific framework, then you would continue to use the term .NET Framework, preferably with a version after, like .NET Framework 4.7, 4.8, and etc. And as you can see, if your application is based on .NET Framework, you have fewer options compared to when you are using the .NET Core. And as part of some of the tools that we will provide for you later on as part of this presentation, you'll see that you have the option of moving your application from .NET Framework into .NET Core and unlocking those additional options that you have on AWS. Our first tool, Windows Web Application Migration Assistant for Elastic Beanstalk. Replatforming Windows Web Application to a managed service like Elastic Beanstalk can be difficult. To help with that, we built Windows Web Application Migration Assistant, which is an interactive PowerShell script that migrates websites and their configuration to AWS Elastic Beanstalk. The Migration Assistant is available as an open source project on GitHub and can migrate entire ASP.NET applications running on .NET Framework in Windows, as well as on ASP.NET Core. It helps you migrate an entire website and its configuration to Elastic Beanstalk with minimal or no changes to the application, and as a result, it increases developer productivity and reduces IT operation overhead. Here's an overview of the migration assistance workflow. Let's assume that you have a web application running ASP.NET or ASP.NET Core on premises. When you run the web application migration assistant PowerShell on the IIS server, first the script automatically discovers and lists any website hosted on the local IIS server. Then you choose the website that you wish to migrate. Then the script checks the selected website's web.config and iterates through its connection string settings. You're then promoted to update the connection string settings to have them point to migrated database instance. So we preferably want the database migrated before. Or again, you can do it later on. After that, the next step will be for this script to generate the Elastic Beanstalk deployment bundle. This bundle includes web application binaries and instructions for Elastic Beanstalk on how it should host the application. Finally, the script uploads the deployment bundle to the Elastic Beanstalk instance for hosting. And you can run it with different versions and different applications. This is an actual screenshot of the Windows Web Application Migration Assistant. As you see, we've run the script up there. It's scanning the local environment. As you see on the IIS server, it has found the default website and this NOP 4.2 based application. The admin has chosen the NOP 4.2 for the migration. It has found the path, it's generated the bundle, the JSON that has all the information in it, taken some snapshots, then uploading it to the instance, and then a log of whatever it done about the instance that it's running on. As you see, we have the ARN of the Elastic Beanstalk, as well as some more information on the migration result. So that was one tool. The other one is about containerization. Containerizing your applications from .NET Framework to .NET Core can be difficult. AWS App to Container, or A2C, as the acronym goes, is a command line tool for modernizing .NET and Java application into containerized application. App to Container analyzes and builds an inventory of all applications running in virtual machines running either on premises or in the cloud. You simply select the application you want to containerize, and A2C packages the application artifact and identified dependencies into container images, configures the network ports, and generates the ECS task and Kubernetes pods definitions. It can help with converting an entire website and its configuration to Windows container with minimal or no changes to the application. So let's see how it works under the hood. Let's assume that you have a running application that is using Microsoft IIS. When you run the app to container PowerShell, it discovers and inventories all IIS sites capable of being containerized. You would select the IIS site, then app to container analyzes the dependencies and IIS configuration. And again, same as the previous tool, you have the option of updating the database connection string. After that, it extracts all the necessary artifacts to containerize the application. And once that part is ready, then those artifacts are uploaded to an S3 bucket. From there, you can build and push the container image to Amazon Elastic Container Registry, or register as a task in Amazon Elastic Container Service. It also allows you to generate deployment files to be used in Kubernetes using Amazon Elastic Kubernetes services. Again, some screenshots from it. I hope it's actually visible enough for you to see. Again, we run the application. It has scanned it. It found some images out there. It is deploying and it's actually generating the image for it, then uploads it to AWS as it was mentioned before. Of course, this screenshot is not the complete screenshot of all the steps, but you get the idea of what to expect when you're working with this tool. Windows Server 2003, 2008, and 2008 R2 already reached their end of support. Windows Server 2012 and 20 R2 will soon join the club on October of 2023. But there are still legacy applications which are only compatible with these older operating systems, and customers still want to run these applications without making any code changes to make the application work on the newer operating system. Sometimes, even if they want to, they don't have the source code or the resources to begin with. That's where the end of support migration program, or EMP, tool and process is for Windows Server helps customer with the migration. It helps them to package the legacy application, allowing them to run that package application on newer Windows Server OS without changing any code. After going through the EMP process, legacy application is wrapped in an EMP compatibility package, which intercepts calls made by the application to the underlying operating system and resolves all incompatibilities while maintaining the complete application behavior as is. EMP compatibility package achieves this through its three key features: redirection, isolation, and compatibility. With redirection, compatibility package intercepts any API calls that legacy application makes to the OS and resolves possible incompatibilities. For example, if the application depends on an older version of .NET, like .NET 1.0, this older runtime is included in the package itself, and any call legacy application makes to the underlying operating system for .NET runtime is redirected to the .NET runtime included in the package rather than the one installed on the operating system. Similarly, the package can perform redirection for registry keys, hard-coded Windows files, network ports, and etc. Isolation. This feature allows the compatibility package to run several versions of a runtime on the same operating system. The older runtime is isolated from the external environment and can only be accessed by the legacy application. This further improves the security posture as well. And of course, then the compatibility area, the EMP provides application to operating system compatibility while maintaining the application behavior, and integrates with other application tiers, database, services, and etc. Additionally, EMP solves for several operating system incompatibilities like DEP, COM virtualization, or even just reporting different version back to the operating system to make the newer operating system behave and look like the old one to the application itself. Pretty much we're putting the application into a bubble and give it everything that it will need using the EMP. Another tool, if you've already have not enough of our tools, enough information about our tools, there's another tool called Porting Assistant for .NET. This tool is an analysis tool that scans .NET framework applications and generates a .NET Core compatibility assessment. helping you port your applications to Linux faster. Porting .NET Framework applications to .NET Core help customers take advantage of the performance, cost-saving, and robust ecosystem of Linux. However, porting application to .NET Core can be a significant manual effort. Application owners need to spend valuable time identifying the dependencies and APIs that are incompatible with .NET Core and estimating the level of effort involved. Porting Assistant for .NET quickly scans the .NET Framework applications to identify those incompatibilities with .NET Core, finds known replacement, and generates a detailed compatibility assessment. This reduces the manual effort involved in modernizing your application to Linux. Porting Assistant for .NET is available as a standalone tool or as a Visual Studio IDE extension. Porting Assistant for .NET is an open source tool, and you can find the source code at its GitHub repository. What it helps you with is actually, there are different areas that this assessment can help you. Quickly prioritizing. Porting Assistant for .NET enables you to scan your entire .NET application and generate the assessment reports. This makes it easy to prioritize application for porting based on the level of effort required. And of course, it removes the need for you to manually go through the source code and kind of determine those incompatible parts and replace them. I have some screenshots here for you. Here, the Porting Assistant tool, it has actually loaded a Microsoft Visual Studio-based solutions. And within the solution, naturally, you have different projects, and it lists all those projects as well. It actually, by scanning the source code and the configuration, it determines the mapping and how these different projects actually interact with each other as in the project reference graph. It gives you visibility into each source file. As you see, all of those source files, those CS files are listed here with the incompatible API counts listed here and the portability score. This one will tell you which one is easier to migrate and which one needs more time and effort. And finally, the actual source code. It actually goes there, highlights your source code, tells you what the reason of incompatibility is, and it actually gives you some recommendation as well, what you need to do to update this line of code to be compatible with .NET Core. Definitely, it's on your own discretion to use this recommendation or to follow your own, but the main part is to actually be able to catch these incompatibilities in an automated fashion. And Porting Assistant for .NET is an invaluable tool from that perspective. Another aspect of the migration could be the re-architecting phase, and through which you would actually move, for example, from monolithic to microservices, or embrace deep code changes to be able to use cloud-native services more efficiently. AWS Microservice Extractor for .NET simplifies this process. Modernization and transformation of your application with an assistive tool that analyzes source code and runtime metrics to create a visual representation of your application and its dependencies is an invaluable feature. With Microservice Extractor providing automated recommendations, developers get guided experience to refactor legacy application. Microservice Extractor now identifies common extraction candidates using heuristic-based technologies and highlights those in visualization. These recommendations can be used as is or used as a starting point to extract microservices off of monolithic code base. Thus, automated recommendations from Microservice Extractor helps you speed up refactoring large applications, even if the developer is unfamiliar with the code base. You can also extract the code base into separate projects that teams can develop, build, and operate independently to improve agility, uptime, and scalability. So different steps for how it works. It actually scans your application. Using those heuristic-based technologies, it tries to group similar ones or those components of your application that interact with each other more frequently. Of course, there's a preparation phase for extraction and decoupling of those proposed groups, and then the actual extraction. And as a result, at the end of it, you will have the code that are modified to produce different services and those services are grabbed from your original source code. Analysis phase creates a graph view of the customer application. This view includes both static code analysis and added runtime. And of course, it will help you understand what your code does and how it interacts with different modules that you might have with your code. This is a screenshot of that phase, the analyst phase. It actually shows you graphs like this and prepares you for the extraction. With the extraction, you have some automation regarding replacement of local API calls with REST calls that is more suitable for the microservices-based architecture. And then code projects regarding that. And then you have the option of extracting those groups. And eventually, when you're done with that, it will give you extracted source codes as well. So this is how it used to look like. And after that, it looks like this now. So that can actually help you with the actual refactoring. That was a lot of tools out there. We can definitely use a tool to manage all these tools, right? That's what Migration Hub is all about. Remember at the beginning of the presentation, we talked about the 3 phases of migration. AWS Migration Hub helps across all these 3 phases. Assess by obtaining EC2 right-size instance recommendations, for example, or in the mobilize phase, discover and plan in your migrations using the information gathered from customers and from the scan result of the assess phase. You can recommend us which tool is the best tool for use with this migration project we have at hand. And of course, the actual migration. It tracks the application migration, and all those happens in a single pane. A component of Migration Hub is the strategy recommendation that it can help you determine which tool to pick among this long and growing list of tools that we discussed so far, and maybe we will have in the future. So as you see, the recommendation could be to rehost it on an EC2 instance, move it to Elastic Beanstalk, refactor it to containers. If you have some programs that you can leverage to free yourself from those licensing restrictions the third-party vendors will put on you, it can actually give you recommendations around that, refactoring. All those recommendations are part of what the strategy migration does for you. Similar to other tools, it will need some data. It will analyze your source code, connection strings, artifacts that are keeping your source code up and running, and then creates recommendation. It not only uses the analytics, but it can actually, and it needs some feedback from you as the application owner. So this is how you set it up. There's a little collector that analyzes the environment, and then this is the questionnaire part, which kind of incorporates your idea of a successful migration into the analysis as well. So it will ask you a bunch of questions about what your preferences are. And then using those information and the analysis tools, it will actually give you some recommendations in a screen like this. Gives you the tool recommendation, gives you the strategy, and of course, each of them, you can have the option of going deeper into the recommendation. Anti-pattern reports, when you're deviating from best practices, it can also help you identifying that. Okay, we're done with going through the list of our tools. What we have now is a little demo that my colleague Siavash has created for you. We won't be able to hear the audio of it, so I'll try my best to actually dub over the audio. What we're showing you here is the lift and shift scenario using the AWS migration service. The AWS migration service is the successor to the Cloud Endor tool that you most probably have used before while working with your customers. Quite similar architecture. You have the MGN agents running on premises. And again, as I told you, we have a dedicated appliance for VMware environments as well that can replace those agents. Those agents or appliance will have continuous block level replication to the server that's running in the staging area. And per each drive that you have in your on-premises, you will have an EBS attached to the staging area server. You have the control that goes to the AWS MGN console using port 3, but this replication happens directly between the agent and the replication server. Typically, it's on port TCP 1500. Once this replication is done and you're ready for a test or cutover instance, what the service does for you is it will actually create a launch, some EC2 instances based on the launch template that you define for the MGN, and you will hydrate its data drives and the operating system drive using those snapshots that we have on this staging area. It will inject the necessary drivers as well, of course, and creates the environment, prepares that instance to be running on EC2 environment on AWS efficiently. And then after that, you have the option of testing your application. And let's see what our demo does for us. So it's a two-tier application. The front tier is running PHP on IIS, and the backend is running a SQL Server. And it's a pretty primitive application with a simple connection to connection suite. This is your on-premises web, and this is your on-premises SQL Server this is the actual database server with a simple table running on SQL Server. Here is the console for the application migration service, through which it will actually give you option to add servers. It redirects you to the place that you can actually download the replication agent. We have already downloaded it here. We will go through the configuration phase of it. Right now, as you see, there are some parameters that you need to provide to the installation, to the replication agent. You can do it interactively the way that we do it here. Or when you click the add server in the console, it will actually bundles up all the answers as part of the command line parameters, and you can actually run it in an unattended mode on your actual servers. Different information we need to provide here, like the region that is going to be the target of our replication. Of course, any API calls with AWS requires credentials, so you need to have access key and secret keys. It will ask us which drives on the server we want to replicate. If you don't specify them, it will simply replicate all of them, and that's what we are going to do. Just replicate all of them. And pretty much That's it when it comes to Q&A. It will download the latest binaries. It will run it on the server, and same thing happens on the other one. So for each server, you need to run the same wizard. Once you're done, you will see that your servers will start to automatically pop up in the AWS MGN console. There it is. The second one just popped up as well. Here's where we fast forward the video because, yeah, usually it will take a few hours. Some statistics for you. As you see, this one took us over 90 minutes for a full replication for 30 gigabytes of data. And within each of these configuration, you can and you should actually define the launch template that they, later on the migrated instances will want to use. But we're not going to deep into that configuration of that. But you have the option of defining what instance type, which VPC, and what other attributes you want to have. What we're doing here is to add some dummy data into the source environment just to show you that those added environment, those added data are also replicated using MGN, and we are not losing any data while we're using the MGN block level application. So here, we have the migration lifecycle says ready for testing. Now we're actually testing these instances that are been replicated into AWS. Test in progress. What we're generating an EC2 instance out of those snapshots, there are different steps that we will go through. And as you see, we're listing all those steps. Taking the latest snapshots, converting them, generating another EC2 instance, attaching those snapshots, those EC2 instances. So there are different phases of conversion that goes through, and we'll give you visibility. Once we see that those instances are generated, you see we have the instance ID. We go to the EC2 console now, and there they are. These are the instances that are regenerated from those snapshots that we got from your on-prem environment. Let's see if they actually work. You see we have both drives. This is the actual staging server, that it has the 30 gig and the 50 gig from both servers attached to it as volumes. There it is. The 30 gig is attached to your web server, but let's see if the application actually works. We're going to browse the same thing, and as you see, all the data, including the latest one, while the replication was happening, is replicated using this MGN tool. And when you're happy with these test instances, you see all the functionalities there. The next step in the migration lifecycle is to create cutover instances. Pretty much they're the same thing as the test instance, but it gives you the option to mark the stage of the migration that you're in. In terms of technicality underneath both test and cutover instances, they're the same. They both follow your launch template. They will, and yeah, pretty much give you the same experience. We're definitely not going to show you that. And that is pretty much it. Once you cut over into it, Then you have the option as the later phases in the migration. If the cutover instances are successful, you will mark the servers as archived, and with that process, it will remove the agent from your source instances. And typically at that point, you want to shut down your source servers. And this is how you would do a lift and shift migration with AWS MGN. We're only 5 minutes into the time up of the hour. So our call to action: learn more about Windows on AWS at aws.amazon.com/windows. Establish early wins by using AWS MGN as the lift and shift. Usually that's the approach most of our customers take, at least early on into the journey into the cloud. Revisit your .NET applications and look for opportunities to modernize, and definitely keep us, the Microsoft specialists, sellers, and solutions architects, involved in your opportunities in case you think that you can leverage our help. We're here to help you in both assessing, in all of the assessing, training, and architecting the solutions that you might have for your customers. We have, for example, lab modules for each of these tools that you saw today. We have labs that we can present and workshops that we can present to your customers as part of an .NET-oriented immersion days or Windows-oriented immersion days. Even when it comes to operating those workloads in the cloud, integrating it with services like SSM for management or CloudWatch for monitoring, my broad team can help you with that and get your customers up and running in AWS Cloud. So we, Microsoft specialist sellers, and SAs are a team that are here to augment your capabilities when talking Microsoft to our AWS customers. And with that, I pass it to you. Thank you all, and hopefully to see you soon in the other partner cast session. Back to you, Karen.